Hello again. This is the final video, um, and this is optional. If you are not interested, skip this video. Here we'll speak about what is called big query, and a big query is like a component in a Google Cloud platform in which you can upload tables in a way like MySQL, but it is uh, like customize it for Google. So um, how we can do this? Just open um, what is called BigQuery like this. So BigQuery and for your project, you can create a table or data set for your project. So this is my project. Let's click and create data set, and let this set to be called MNest. And what is the location? Let it in North America, uh, Northeast too, and leave everything as a default. Just create a dataset. After we created dataset, we can add a create table within this dataset. So just create table, and there's many ways to create table. Maybe empty table, maybe Google Cloud Storage from Google Cloud Storage, or upload one Google Drive, Google Cloud Big Table, or Amazon um, uh, S3 whenever you want. So let's start with Google Cloud Storage. I want it from Google Cloud Storage. And what is selected is the Google Cloud Storage bucket. So let's open my bucket like Google like cloud storage, and within it go to input, and from input there is image.txt that is the file contains uh, my dataset. So let's maybe copy git URL or this URL. Let's check this. What is copied here? Paste. Not this. So maybe copy JSUTL URI. Okay, that is what I need. So go to the configuration of BigQuery, and with this link here, then it shows that it is a CSV file. And also what is it, as a project that set of this will be left like this. And what is the table? Let's call this table like image. And for the schema, this table has as we seen before, has two fields. One of them is key, which is a string, and it is like this, and the other is maybe image, and also it is a string. Then to the advanced object, how is this parsing? What is the separators here, or delimiters? The delimiter is not comma, it is just custom and to be colon. So if what I did is correct, hopefully so, I just click create table, and this will be created. Okay, there is no error, so it is created like this. We can also query it like this. Select asterisk from this table, and you can see that is a project ID dot the dataset ID dot the table name. So just like this and run. And here the data is correctly loaded. Okay, now we have loaded the input data. So what we'll do, we will write another version of our code, which is called version 4. And in version 4, there will be another option if the source with BQ. That is will be our pipeline, and for this pipeline we start by reading from BigQuery source, and this source is given from the input argument, and what is read will be already dictionary, just will provide it to the function predict that do the prediction, and the output will still dictionary, so just we provide it to another function which is write to BigQuery sync. So just this, it's read from BigQuery source and write to BigQuery sync. And for BigQuery sync, we don't need only the output, which is the table name, but also we need the schema so that this table can be created. And what is the schema here? It is just 11 field, and which is image key, which is an integer. That is the primary key, and after that we will add this string, this comma, and then will be prediction 0 as a float, prediction 1 as a float, and until prediction 9 as a float. All of this will be the schema. This is a string, just one string that contains the description of the 11 field, and will be stored in a schema, and this schema will be an argument to BigQuery sync, and also create if needed, and write with truncation. All this is configuration, just a configuration. What we need is to run this, and to run this just we have to make the source BQ, and to do this just run it like this. So as you can see, that is for an optional BQ. The source will be BQ, so that this if statement is executed, only this. The parameter will be the same like as a Dataflow runner, the project ID, and the bucket for staging, table, temporary, and model. Setup that will set up the libraries in workers, and also source BQ, which chooses this part. But for here, how we provide the input and output for this code. The input and output is a table. It's in this format, which is the project name, then colon, dataset name dot table name. That is the input, and that is the output. Will be the project ID colon the dataset dot the table name, and other parameters will be the same. So just this is the only changeable here. So let's go. It changes the directory first. I started a new shell, so in this new shell I am at home directory. So what I need first is to change directory to where the file prediction for exists, and then change the environment to the virtual environment. After that, I need to like uh, like set the project variable and bucket variable to project ID and bucket address like this. It's okay, it's set. Then I can run uh, predict version 4 like this. For now, let's open the Dataflow jobs. Okay, there's a problem here. Maybe it is still authentication problem. So it is authentication problem. So let's maybe open a new one, or doing some refresh first. Open new one like this, and after this just okay, okay. Right, so let's repeat the same command again, like change directory, set the virtual environment, and after this get the project ID and bucket ID. After that, let's run uh, our version 4 with a source of BQ. Okay, and now it is working, and as you can see, um, can go to jobs and do some refresh here, and there is a new uh, pipeline like this um, for this processing. And here we have three stages: read from PQ, do prediction, and write to PQ. So we'll wait a little until this executed, and then we can see that we will have another table here, and this table will have the name of the output, and our output was its name was let's open it. Yeah, it's here. As the output will be predict. So mnest will have a new table will called predict. Who is this one? Okay, so let's wait. Yeah, it may need a refresh, but let's wait first until this um, this code is executed. And while waiting for this code to be executed, let's continue investigate version 4. And in version 4, you will find another option which is called PubSub. PubSub is like a customized version of Kafka that is installed within Google Cloud Platform. It is not. It's like a Confluent Kafka, but Confluent Kafka is, you can consider it as a partner platform for PubSub, but this is a part of Google Cloud Platform. So in it, we can create a topic, and we can produce and consume from this topic, and it will work in the same way. It's like Kafka, but it has a different API or a function and library. There is a read from PubSub function that takes the topic name, and we do deserialize uh, as we done before, because this will be in a JSON format, in a byte format, a JSON and convert it into byte. So just we have to convert it again into dictionary, and then send it to prediction. And after this, we start to serialize it again to bytes. And after we serialize it again to bytes, we send it to PubSub. That is exactly like Kafka code, but the only difference is the function that used to send to PubSub, and function to send to read from PubSub, and these three jobs are the same as in Kafka. So when this code is executed, just we will go and do enabling our PubSub, do some topics in it, and uh, start running it, like sending messages into the input topic and consume message from the output topic. But for PubSub to work with PubSub, you have to go to your service accounts that you have created first and add additional permission to use PubSub uh, admin tools or admin privileged. You have to give it this privilege so that it can work with PubSub. Without this privilege, this function cannot be work. So for now, just we are waiting. And as you can see, the first job is consists of 3 stages. At the first stage is starting, and after it is started, it will pass um, its data, its elements into next stage of the tree. And after this, the second job, which consists of 1 stage, will start to run, and so on. So still waiting for it to run. maybe while we are waiting, let's go and prepare something for the new option. Like go to our account, service accounts, and go to the service accounts that we created first, and go to the permissions. Okay, now it start to work, so we can wait a little and then continue. One stage is succeeded, and data is sent and it is being consumed by other stages. The first job is done, and the second and the third. Now it finished, and it is cleaned up after the pipeline is finished. So let's go to our dataset, and let's refresh the page, again reload, and as you can see, within our dataset there are two tables: image, the original one, and the predict, the created one. So now let's start for displaying all fields from it. Like this, that is how some values are displayed and is predicted. So now it works with BQs. So let's go to our service and continue with PubSub. So for PubSub, we have to like grant access, not like here. Going to rules. Okay, I go to IAM, and from this, that is my service account I created before. So just edit principles, that is the only rule that it has, which is compute engine service agent. Now I'll add another rule, and for this another rule, it will be PubSub admin. That is it. And after this, just save. And now your service account and your data flow has a permission to update. Okay, has a permission to work with PubSub. So now let's go to PubSub. Try to create and to go to PubSub, just you can search for PubSub, or it is right going here for this menu and go downstairs like for here, and this pops up and you can create topic. So go to topic and create topic, and let's call it mnest image. Create a topic, and go to topics also and create a new topic and call it mnest predict. Okay, so how we can run our code? Let's go with let's display two windows here. The first will continue with um, yeah, what is it? Okay, that is the version 4, and this is a part of PubSub. And the second will have our commands here. So just we add a rule for service account, and when we want to run this, it will be the same except the input and output will be written in this format, which is projects, then the project ID, then topics and the topic ID. That is the input and that is the output. So just input and output topics is written in this format. And those will be used as argument, as input argument here for the read from PubSub, and as an output argument here for write to PubSub. So let's run it. And also there is a new um, like an argument is called streaming, because here we will work as a streaming. As we use PubSub, it is a streaming, it is not a batch processing. So just copy and go to our console like here, maybe clear screen, and then run it again. So hopefully it works. Let's check the jobs here by refresh. Yeah, this is a streaming processing here, and if you can see, it consists of read from PubSub or from pub, and to dictionary, prediction, to byte, and to pub. So what we need right now is just okay. What we need right now is just wait for it to be run, and also to write two scripts in my local machine to send data. It will simulate a sensor that will send data to the input like input topic, and another one that will read data from the output topic. So to do this, we can go to our repo again. Okay, where is our repo? That is our repo, and in the mnest folder, we see a folder called data, and within data there is an optional opt, and there are two scripts here. There are for using Google Cloud PubSub. So the problem here is how to set the credentials. So let's check for this code right here. What we need is a credential for our service account, and it will be like a JSON file, and put the name of this JSON file with extension with XPath here in this string, and then the project ID. And when you are doing consumer, we need what is called subscription subscription ID for a given topic. And if we have these three information, we can connect and consume from a topic. And for producer, we need the topic ID, the project ID, and also the service account credential. So let's start by finding how to find the credential. So what we need right now is going to our Google Cloud. Let's open a new one like here. Go to the service, to the account service. Like here, and go to IAM, or maybe a service accounts like here, and go to one that has the same as project name and then -sa that we created before, and just choose keys and add key, and create a new key, and we want it in a JSON format like this, and then we download the file, copy it, and paste it in the same like folder, and take its name and put it in both of them. So just come here and put the file name with path. If it is not in the same directory, you have to provide it with the path, and do save. And also for here, like this. Then the project ID has to be set also, so just go again to your console, okay. Now job is created, so let's create open another one and take the project ID, like copy here from here, and let it paste it here. Again, we need the for the producer, we need the topic ID, and the topic ID here is mnest image. Okay, now this is completed. All the credential and the connection information is given here, so there is no problem. Now let's go to our consumer. We need a subscription ID, and to this subscription ID, we have to go back to the PubSub, and for the topic, which is mnest predict, go and create subscription. Give it a name like mnest image sub, something like this, and take this as a copy, and adjust all the parameters you need, or leave it as a default, and then create. And take the ID that you have set there to, and paste it like here. So that is almost like the producer that we use in Kafka, except in the credential and in function. And to run this, you need a library called google.cloud, and to install it, let's return to our instruction. To install it in your local machine, just run pip install upgrade Google Cloud PubSub Lite. So you just take this, run it as in your command window, and of course it will install the Google Cloud PubSub library in your local machine. So let's change our directory to optional, and start with running the producer. And the producer is the same, just it create a publisher client, and for this publisher client it will be published to project ID and topic ID by reading images in the parent directory, not in the current directory, in parent directory, and open image.txt and take each line, read line by line, and for each line split it by colon into array of two. The first will be the key and the second will be the image, and then started to publish it. And to publish it, we are converting it first to bytes, that is serialized code here, and after this serialized into bytes, we are sending it and publish it and print that the image with that key is sent, and wait for 1/10 of the second. For the consumer, it will be easier. It's like we have a callback function that is called whenever data is received, and just are subscribed with the subscription path according to the callback function. And within this function, which is with subscriber stream poll future dot result, this will check if a new message is received, and if there's a new message is received, it call the callback function, and it will be printed like this. And here is how this code is doing the deserializing into a dictionary. So I hope it starts. Okay, it is running. Its status is running, so it's okay. This is good. Just go here and let's start by running the consumer first. And then write the producer. Now there is keys that are produced. Uh, and it looks like there is a data that is given that is now processed, but we have a problem. No, we don't have a problem. As you can see, that is a consumer, that is a producer, and then the data is processed and put into another topic, and this topic is data, is a result is consumed from this topic. And if you can see, that is the ID, which is 440, and that is the ID is 440. So whenever is produced will be predicted and consumed like here. And as you can see, maybe for the image with key 512, the prediction will be as a second digit, and for the 511, the prediction will be as the digit 4. Okay, now you can stop this. And also this is streaming and will work forever until you stop it manually. So if you wanted to stop this won't stop. Just if you go back, you'll find it is still running. It never stopped. So because this is a streaming, you have to go and click stop yourself and cancel and stop job. And now you have accomplished the MNIST prediction with five input-output sources. Good luck with your project and bye-bye.